Hello YouTube. In this tutorial I'm going to show you how to use the Swift dictionary type, um, but this time I'm not going to use a console application. I'm going to use the Playground um, interface by Apple. So to create a new one, just go to File, just go open Xcode, go to File, New, Playground, select iOS, give it a name, press Next, and just press create, but I already have one open, so I won't do that. So if you don't know what a dictionary is, a dictionary is basically an array. Well, its underlying structure is an array, and but instead of by index, you can access the elements by a hashable data type. So what that means is that with a vector, with array, you can say array at index to get the element. However, with a dictionary, you can say dictionary at hashable is equal to something. So the difference between index and hashable is that hashable can be an index, but doesn't have to. So what you can put instead of hashable is a string, or a character, or basically any data type that can be uniquely identified. That is the definition of being hashable. So to create a dictionary, you just use a var keyword and call it test dictionary is equal to dictionary, angle brackets. Now you can decide what data types you want for the dictionary. So I'm just going to use a string and let's say an integer. So why would you create a dictionary in the first place? Well, instead of having an array of contiguous elements, it might make more sense to grab the items by some identifier. So for example, you can create a dictionary that will, let's say in a business, enter the name of the employee and grab his or her ID. So you can say, for example, add an employee. This is how you add items to a dictionary. Just write test dictionary at just use the brackets like you would access an array and put the key you want. So John is equal to, and this would be his ID. So now let's say you wanted to see what ID John has. Well, then you can say John's ID is equal to test dictionary at John. So the advantage of doing this in a dictionary is that if you had an array, to find John, you would have to loop through all of the array and check each element and see if that element is John. That is very impractical. Also because the array type can only take one type of element, which would be either John or his ID. You can't have both unless you put them in a class or a structure, but then a class for just these two elements would be maybe a bit too excessive. We wouldn't want to like create a class just for these two elements. So that is how dictionaries work, and you can create as many elements as you want. And you can access them by this type of thing. But let's say you wanted to access every element. The best way, in my opinion, would be a for in loop. So if you haven't checked out the video on loops, um, you should. I think it's the 5th one. But anyway, to iterate through each item, you can just use a for in loop. So you could say for employee ID tuple in test dictionary. Now, employee ID tuple will represent it's a tuple data type, which means it's a data type that has it's not a class, it's not a struct, it's just more than one element. So you have employee ID tuple, and then you can access each element using the dot notation and getting the thing you want. So at 0 will give you the name, and at 1 will give you the ID. So that is a cool way of iterating through a dictionary. And dictionaries are also very cool because they allow you to save time. Like I said before, if you had to find an element corresponding to John, you'd have to go through each item in the array and check if the name is John. That might take up a lot of time depending on where in the array the desired element is. Instead, with dictionary, a dictionary knows exactly where, with a special formula, it knows exactly where your element is based on the key you give it. But as you may have considered, not every element is hashable. So like a custom class will not be hashable by default, but you can make it hashable. That is the cool thing about Swift. So let's create a struct. So if you don't know what a struct is, it's just basically a container for more than one data type, and it's almost like a class because it can do almost everything a class does. So to create one, you just use the struct keyword. Let's call it hashable struct. Let's say, let's try to use, let's use the same types. So employee and ID. So let's create a variable for the ID. It's an integer. And let's create a variable for the name. That'll be a string. Let's now create an initializer. And let's pass in the ID and the string. So what initializer does is it lets you it lets the user initialize the type with the desired elements as soon as it's created, instead of setting the individual elements later on. So let's delete all of this, and so I'm thinking actually I should just put the name here. Otherwise it kind of defeats the purpose. Okay. So now if we try to insert hashable struct, actually we should put it here. Now it'll tell us that does not conform to protocol hashable because it's not defined as a hashable type. But we can change this. So to make any type hashable, just type colon hashable. Now, we told it has to be hashable, but we need to tell it how. So now let's go into hashable by pressing command click. Now just get this hash value, copy this hash value, okay. Just put return 0. And now let's go back into hashable and just go into equatable too. Copy this. What this does is it's an operator overload. So in what you can do in Swift is overload the default operators in the language. So you could use a plus to like add two vectors, or you can define custom behavior for different operators. But I won't go into this right now. I'll do it in another video. Also, after hashable, just add equatable. So now let's return lhs.name is equal to rhs.name. So it basically we're telling Swift that these instances are equal if the name is equal. Now let's go back into hash value and let's return a custom integer that should more or less be unique for everything we enter. So one thing that could be almost unique is, for example, the length of the string. So I told you before that the underlying data structure for a dictionary is a vector. And the Swift knows where to place the items into the vector based on an index, which will be hash value. So now that we made it conform to hashable and equatable, we don't get complaints from Swift, which can now handle hashable struct as hashable data type. So now let's try to make a new hashable struct. So John, let's say, actually, let's just say test dictionary at hashable struct name John is equal to test dictionary at hashable struct. So now it has the values. So let's say we want to get an ID, and we can just say test dictionary at hashable struct name John, and there we get the number. So you see that the items are indeed hashable now. See, there it is for pop. Another cool thing is that if you try to access something that is invalid, it will not crash. And that is very cool because if you by mistake access something that is not valid, the app will not crash. It will just tell you that there is not an element at that specific key. So it just returns nil and doesn't crash like accessing a vector at an invalid index, an array at an invalid index. So that is all for this tutorial. I'm going to talk about stacks in the next video.